Hello everyone. On this video we will be looking at trig functions of real numbers. Alright, so to start off, let's look at the definition of our trig functions. Okay, make a little table here. Okay, so if we have sine of some angle t, let me focus that a little bit better. There we go. That's going to equal y. Cosine of some function t is going to equal our x. And tangent of t, remember tangent, that's just sine over cosine. Given that cosine doesn't equal 0. Or y over x, again, cosine of t does not equal 0. Okay, now let's look at our other three functions. Okay, our other three functions are just reciprocals of the three functions here. Okay, so you have cosecant of t, okay, which is cosecant, and that's just the reciprocal of sine. That's 1 over sine. Okay, where of course sine does not equal 0. Okay, then you have secant, which is secant of t, and that's just the reciprocal of cosine. That's 1 over cosine of t, where of course cosine of t cannot equal 0. Okay, so now we have cotangent, which is cotangent of t, which is the reciprocal of tangent. And the reciprocal of tangent is just cosine over sine. Where of course in this case sine of t cannot equal 0. Okay, so we have our sine, our cosine, and our tangent. I'll put that under here. Our cosecant, secant, and cotangent. Okay, so those are our 6 trig functions. Okay, so we can see there that, of course, those are just reciprocals of each other. The sine and cosecant, reciprocals of each other. The cosine and secant, reciprocals of each other. And tangent and cotangent, reciprocals of each other. Okay. Now, according to quadrants, some are positive in certain quadrants and some are negative in certain quadrants. Remember that sine is equal to y. Okay, so if we have our x and y axis, then remember this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Move that up a little more. There we go. We see in quadrant 1, all of those are positive. Okay. In quadrant 2, remember, x is negative and y is positive. That means sine cosecant are positive. Okay, everything else is negative. Remember, x is negative in quadrant 2. So if x is negative, that means cosine is negative, tangent is negative, cotangent is negative, and secant is negative. Now in quadrant 3, all of your tangents are positive. So tangent and cotangent are positive. Again, because x is negative and y is negative. So if x and y are negative, that means these 4 are all negative. But negative divided by negative will give you a positive. So that's why tangent and cotangent are positive there. Okay, now in quadrant 4, cosine and secant are positive. Why? Because in quadrant 4, x is positive, y is negative. So if this is positive, then this is positive. So these 4 will all be negative. Okay. All right. Now, the one way I usually use to know which ones are positive in which quadrant is to make up a little rhyme. Okay, you know they're all positive here. Here, going, of course, counterclockwise, I have single cosecant. Let me clean that up. Tangle cots with cozy secrets. Okay, now does this make sense? Absolutely not. But it can be helpful to make up something like this. Because, you know, they're all positive here. You have sine, cosecant. That's my little trick there. Sine, cosecant, positive here. Tangent and cotangent. Tangent, cotangent, it's positive here. Cosine and secant, cozy secrets, it's positive here. So if you're ever trying to figure out which quadrant their positive is, they're all positive in one. Single cosecant, tangle cots with cozy secrets. Like I said, it does not make a lick of sense, but it can be helpful in memorizing this. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next page. And those are your values of sine and cosine at certain values of t. Okay, so again, we're going to make our graph here. Okay, so this is our t. Okay, so this is, we'll have our y, which is our sine. And I'll move that down a little. So this is our sine of t. Our x is cosine of t. And our tangent, remember that's just sine over cosine. Okay, and the rest of these are just reciprocals. Okay, so we have cosecant of t. Remember, that's just the reciprocal of sine of t. We have secant t, which is just the reciprocal of cosine. And we have cotangent t, which is the reciprocal of tangent. Okay, so really once you have your sine and cosine, kind of draw that there, the rest of these can be figured out. And I'm going to show you the best way to remember all of these values. Now, if you look back at my unit circle video, I showed you how to do this on the unit circle. This is just showing you how to do this in a regular graph. Okay, so we have 0, power over 6, power over 4, pi over 3, and pi over 2. All right. So if you remember, starting with your y, you go square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and square root of 4 over 2. Okay, you always start with your y. So you're going with 0, pi over 6, which is 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay, so starting with just with those values, once you get your 0, pi over 6, pi over 4, pi over 3, and pi over 2, starting with y, you go from 0 on up to 4. Well, square root of 0 on up to square root of 4, so that's 0, 1/2. Square root of 2 over 2, you keep that as square root of 2 over 2. Same thing with square root of 3 over 2. And square root of 4 is just 2, so you have 2 over 2, which is 1. Alright, so now with cosine, you do the same thing, but in reverse. Okay, so you go square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and square root of 4 over 2. Okay, so that's 0, 1/2, again, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2 is just 1. Okay, so we know sine of 0 is 0, sine of pi over 6 is 1/2, sine of pi over 4 is square root of 2 over 2, sine of pi over 3 is square root of 3 over 2, and sine of pi over 2 is 1. Now cosine of 0 is 1. Cosine of pi over 6 is square root of 3 over 2. Cosine of pi over 4 is square root of 2 over 2. Cosine of pi over 3 is 1/2. And cosine of pi over 2 is 0. Okay? So now that we have those, all of these will be really easy. Okay? So remember, tangent is just sine over cosine. So tangent of 0 is just 0 over 1. Okay, so 0 over 1, or just 0. Okay, so tangent of sine over cosine, so tangent of pi over 6 is 1/2 over square root of 3 over 2. Okay, so 1/2 divided by square root of 3 over 2 is just really 1/2 times 2 over square root of 3. So that would be 1 over square root of 3. And if we rationalize the denominator, it's just square root of 3 over 3. So really we just multiply the numerator and denominator by square root of 3 and rationalize it. Okay. Now, square root of 2 over 2 divided by square root of 2 over 2, anything divided by itself is just 1. So tangent of pi over 4 is just 1. Okay, so tangent of pi over 3, just square root of 3 over 2 divided by 1/2, which will end up being just square root of 3 over 1, or just square root of 3. Okay? Now, tangent of pi over 2 is 1 divided by 0. So actually that's undefined. Alright, so now we move on to our cosecant, which is just the reciprocal of sine. Okay, so we get our 0. We can rewrite that as 0 over 1. If we find the reciprocal of that, it's 1 over 0. Or 0 over 2, rather. So 0 over 2, if we find the reciprocal of that, it's 2 over square root of 0, which is, of course, undefined. Okay, so here we have 1 over 2. The reciprocal of that is 2 over 1, which is 2. We have 2 over square root of 2 over 2. The reciprocal of that is 2 over square root of 2. Okay, which actually, if we multiply both of those by square root of 2, or we get 2 and make that square root of 2 times square root of 2, those cancel and you end up with just square root of 2. Alright, so now you have square root of 3 over 2. The reciprocal of that is 2 over square root of 3. So if you multiply this by square root of 3 over square root of 3, you end up with 2 square root of 3 over 3. Alright, and of course if you have the reciprocal of 1, it's just 1 again, so we just leave that as 1. Alright, so now we go ahead and move on to our secant, which is the reciprocal of cosine. So we get all of our cosine values and we just flip them. The reciprocal of 1 is just 1. The reciprocal of square root of 3 over 2 is 2 over square root of 3, which is 2 square root of 3 over 3. Okay, the reciprocal of square root of 2 over 2, we figure that out, that's just square root of 2. 2 over square root of 2, which is 2. Oh, square root of 2, sorry about that. Okay, so now the reciprocal of 1/2 is just 2. And the reciprocal of 0 over 2 is 2 over 0. Anything over 0 is undefined. Okay, now with cotangent, we just find the reciprocal of all of our tangent values. Okay, so the reciprocal of 0 over 1 is 1 over 0, which is undefined. The reciprocal of square root of 3 over 3 is 3 over square root of 3, which once we rationalize it, it becomes square root of 3. Okay, the reciprocal of 1, of course, is just 1. The reciprocal of square root of 3 is square root of 3 over 1, which is the same as saying square root of 3 over... Nope, where is that? Yep, 1 over square root of 3. Sorry about that. I knew I mixed up somewhere. 1 over square root of 3, which is square root of 3 over 3 once you rationalize it. Okay? And you have the reciprocal of 1 over 0, which is 0 over 1, which is 0. Alright. So, that gives us all of our trigonometric values for those specific values of t. Alright, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our first example. Alright, so let's say, for example, if cosine t is equal to negative 4 over 5, and t is in quadrant 3, find all values of the trigonometric functions at t. Okay, so in other words, they're giving us cosine. So by giving us cosine, they want us to find sine and tangent and secant and cotangent. They want us to find the rest of the other 5. Okay, so now we all know that sine and cosine is what we're looking for. All right, so once we find our sine and cosine, we're good. Okay, so we know it's in quadrant 3, so we're going to go ahead and just draw a little XY axis to help you visualize. We have our X and we have our Y. So if it's in quadrant 3, it's going to look something like that in quadrant 3. Okay, so we know in quadrant 3, this is negative 4 or 5, but we don't know which one is negative yet. We don't know if it's a negative 4 or if it's a negative 5. So what we do is we look at the quadrant. So if it's in quadrant 3, we know X is negative. Okay. And we know that our Y value is negative. All right. So that still doesn't help us out, but we can still figure it. Okay, so you know that cosine is adjacent over hypotenuse. Okay, how does that help us? Because if we have our t, well, I'm going to change that to t so it's not flipping around as much. We have our t, our adjacent is here, and our hypotenuse is always going to be positive because this is our X and our Y. Our hypotenuse is always going to be positive. Okay, so since our hypotenuse is always going to be positive, that means our 4 is what's going to be negative. So that means we went negative 4 in this way, and we have to figure out what's here because we know that our hypotenuse is positive. Okay, so we know whatever goes here is going to be negative. All right, so how do we figure that out? We use the fact that x squared plus y squared equals 1. Okay, so that means sine squared plus cosine squared, or you can go cosine plus sine, doesn't matter which order. I always do sine squared plus cosine squared equals 1. And again, I just switch those around because y is sine and x is cosine, but it's just habit for me to put it like that. So don't think that I switch those up. All right. So we already know our cosine. It's negative 4 over 5. So that's sine squared plus negative 4 over 5 squared equals 1. Okay, so negative 4 over 5, that's 16 over 25. So if we subtract that from both sides, we have sine squared equals 1 minus 16 over 25. Okay, because that's our negative 4 over 5 squared. So if we simplify that, we end up with sine squared is equal to 9 over 25. So all we did is make the 1 25 over 25 and subtract our numerator. Okay, so if we square root both sides, the square root of sine squared is just sine. So we square root both sides, and that equals positive or negative square root of 9 is 3, and square root of 25 is 5. Okay, but we already know that it's in quadrant 3. And in quadrant 3, your sine is equal to y, which is negative. In quadrant 3, y equals sine t is negative. So we know that sine of t is equal to negative 3/5. Okay. Now, since we know this is equal to negative 3/5, and sine is equal to opposite over hypotenuse. So sine is opposite over hypotenuse, it's opposite over hypotenuse. So that means this is our negative 3. All right. So that kind of helps you visualize it. So now we can use this sine and the cosine that we started with and figure everything else out. Okay, so we know that sine of t equals negative 3/5. And cosine of t is equal to negative 4/5. Okay, now if you want, you can use tangent to equal sine over cosine, or you can use the triangle. And I'm going to use the triangle. So tangent, remember that's opposite over adjacent. Okay, so opposite is negative 3 and adjacent is negative 4. Okay, so you have the opposite over adjacent. So that's negative 3 over negative 4, or 3/4. It'll be the same thing if you divided negative 3/5 divided by negative 4/5. You'd end up with positive 3/4. So either way, it depends on you. Okay, so now let's do our negative or cosecant theta, which is just the reciprocal of sine. Oh, not theta, t. Okay, so the reciprocal of sine is just negative 5/3. Okay, so if we do secant, that's just the reciprocal of sine. So instead of negative 4/5, it's just negative 5/4. Just flip it around. And tangent, we have our cotangent, which is the reciprocal of tangent. Okay, instead of 3/4, it's 4/3. Okay, so that's how we find all 6 trig functions. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. All right, let me clean that up. There we go. So let's say, for example, we want to write secant of 255 degrees in terms of a secant of a positive acute angle. Okay, so really all that's asking us to do is rewrite this, but instead of 255 degrees, we want that to be a positive acute angle, so less than 90 degrees. All right. Okay, so what do we do first? Well, we're going to get that. We need to find the quadrant first before we can do anything else. We have to know what quadrant this is in. So first, find the quadrant. All right, so to do that, we draw our quick little XY axis. We have our X and we have our Y. Okay, so we know that moving this direction, this is 90 degrees, 180 degrees, 270 degrees, and 360 degrees in a full circle. So 255 degrees is somewhere in between 180 and 270, and let's say it's about right here. So 255 degrees, somewhere around there. Okay, so we know it's in quadrant 3. Okay, so 255 degrees is in quadrant 3. Okay, so in the second step, we found our reference angle. So we find reference angle. Okay, so since 255 degrees is in quadrant 3, use the reference angle formula. T equals T minus 180 degrees, or T equals T plus 180 degrees. Okay, so in quadrant 3, it can be either one of those. Okay, so now if we go ahead and plug those in, your reference angle equals, your T is 255, so you have 255 minus 180, or T equals 255 plus 180 degrees. Okay, so in this case, we have T, your reference angle T bar is equal to 75 degrees, or your reference angle is equal to, adding those two, 435 degrees. Okay, now the thing is, both of those are correct. But for this particular problem, they want the acute angle. Remember, acute is less than 90 degrees. So we can't use that one because it's not acute. It will give you the right answer, but just not the right answer for this particular problem. Okay, so this is the one we're going to use. Okay. So for our third step, we're going to use the quadrant to show if the reference angle is positive or negative. Use the quadrant to show if the reference angle is positive or negative. Okay, so we know that secant is negative in quadrant 3. Okay, so that means that secant of 255 degrees is equal to secant of 75 degrees. But because it's in quadrant 3, it would be equal to negative secant of 75 degrees. Okay, so that's why the quadrant, once again, is very important. All right. Okay, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Okay, so for this example, we want to know what is the value of cosecant of theta if the terminal side of angle theta intersects the unit circle, in the first quadrant, at x equals 13 over 24. All right. So, how do we solve this one? Well, the one thing you want to remember well, actually a couple of things you want to remember. So remember that on a unit circle, x squared plus y squared equals 1. Okay. Also, we know that x is equal to cosine theta, y is equal to sine theta, and cosecant is 1 over sine theta, the reciprocal of sine. All right, so if you remember those three things, we have everything we need to solve this problem. Okay. So, since x squared plus y squared equals 1, move that up. And we know that x is equal to 13 over 24. It's 13 over 24 squared plus y squared equals 1. Okay, so if we subtract that on both sides, we have y squared equals 1 minus 13 over 24 squared. Okay, so if we go ahead and simplify that, that gives us y squared is equal to, I'm going to leave that for now, because 13 squared over 24 squared is 169 over 576. Okay, so that 1, to get our matching denominators, we're just going to make that 576 over 576. Okay, so that means that y squared is equal to 407 over 576. Okay, so if we square root both sides, it means y is equal to the square root of 407 over the square root of 576. Nope, plus or minus. Okay, so y is equal to, because it's in quadrant 1, the first quadrant, we know it's going to be positive. So it's going to be positive square root of 407 over the square root of 576, which is 24. Okay, so we have our y value. So that means that your ordered pair, your xy, is equal to, we have our x, so we have 13 over 24, and your y is going to be your square root of 407 over 24. Okay, so we have our x and our y. But remember, your x is equal to cosine, and your y is equal to sine. We're looking for cosecant. Okay, so since cosecant theta equals the reciprocal of sine, that means cosecant of theta is equal to 24 over square root of 407. And you can leave that as your final answer. You don't have to rationalize it, but sometimes the question may ask for you to rationalize it, but in most cases that should be good enough. All right. So if you are still writing, feel free to press pause. Let me write this little note down. Not necessary to rationalize, but may be requested. There we go. Alright, so if you are still writing, feel free to press pause. We'll go ahead and move on to our next example. Okay, so let's say for this example, we want to find secant of b, where b is equal to pi over 3. So in other words, find secant of pi over 3. Alright, so what I want you to do is go ahead and press pause and try to solve this one on your own. Alright, so I'm assuming you have pressed pause and you are all done. So let's go ahead and verify your answer. Okay, so we know that cosine of pi over 3 is 1/2. Okay, so that means that secant of pi over 3 equals the reciprocal of cosine pi over 3. Okay, so secant pi over 3 is just, instead of 1 over 2, it's going to be 2 over 1, which is just 2. Alright, so let's try another one. What if we want to find tangent of A, where A is equal to 45 degrees? Again, just find tangent of 45. Okay, so again, I want you to press pause and try to do this one on your own. Alright, so I'm assuming you've pressed pause and you're all done. So let's go ahead and verify your answer. Okay, so remember, tangent A is equal to sine of A over cosine of A. So tangent of 45 degrees is going to equal sine of 45 degrees over cosine of 45 degrees. Remember, 45 degrees is just pi over 4. Okay, so that's going to equal square root of 2 over 2 over square root of 2 over 2. Anything divided by itself is just 1. Alright, and that's how you do the basic trigonometric functions for specific values. Alright, so hopefully this made sense, and I will see you on the next video.